Hi everyone. So we'll see few more problems on DC circuit, DC transients. That is, if you see the problem statement for the circuit shown in figure, find the current equation when the switch S is changed from position 1 to position 2 at t is equal 0. When it is changing from position 1 to position 2. Earlier it is at position 1. Now it is changing to position 2. Then what is the current equation that we need to find out? In this circuit diagram, in this figure, 100 volts, 20 ohms, 30 ohms and zero point 0.2 Henry. So for the above circuit diagram, when the switch is at position 2, when the switch is at position 2 means from position 1 it is moving to position 2. The current equation can be written by using or we can find out the current equation by using the KVL equation. As a first step, you have to find out the KVL equation. So that's what we are doing here. So when the switch is moved to the position 2, only this is the closed path. For this closed path, if you apply this is I, KVL equation, 30 into I plus 0.2 into di by dt, because voltage across inductance is L into di by dt, which is equal to 0 because there is no source. This is a closed loop when switch is moved to second position. So 30 into I plus 0.2 into di by dt is equal to 0. By dividing on both sides with 0.2, you will get the differential equation as di by dt plus 150 into I is equal to 0. 30 by 0.2 is equal to 150. So this is your first step as first equation. Then what is the second step? Compare with the known differential equation. The known differential equation is nothing but dx by dt plus px is equal to k. And if you compare both the equations, x is equal to I, p is equal to 100, k is equal to 0, p is equal to 150. So what is the solution of this second equation, non-differential equation? X of t is equal to e power minus pt integral k into e power plus pt into dt plus c into e power minus pt. By substituting this x, p and k in this equation, you will get the I of t or current equation as e power minus 150 into t, because p is equal to 150. Integral k is equal to 0 into e power 150 into t dt plus c into e power minus 150 into t. As this first term has 0, that entire term will become 0. 0 plus second term is as usual e power minus 150 into t into c. So I is equal, finally we'll get it as c into e power minus 150 into t. That is the third equation. First step, second step, third step. Then fourth step is use the initial conditions, because in this equation you have one arbitrary constant. You need to find out that c constant. For that, use the initial conditions. What are the initial conditions? T is equal to 0 minus, t is equal to 0 and t is equal to 0 plus. What is the position of the switch that you mentioned? At t is equal to 0 minus means before the switch is moved from position 1 to position 2, the switch is initially at position 1. Later, at t is equal to 0, the switch is moved to position 2. Further, it remains at position 2. That means initially the switch is at position 1 earlier, that is 0 minus. At t is equal to 0, the switch is moved to position 2. 0 plus also at position 2 only. What is the current when the switch is at position 1? If you see at position 1, the circuit diagram will become 100 volts, 20 ohms, which is position 1 means it is short circuit. This side it is open circuit. Simply it is short circuit, 30 ohms and 0.2 Henry it is connected. But if you see 100 volts, 20 ohms, 30 ohms, in steady state inductor will get short circuit, because earlier the switch is at position 1 for longer time. This is your position 1. The switch is at position 1 for longer time. That means longer time means it is in steady state. In steady state, the inductor will get short circuit. Capacitor will get open circuit for the DC source. So inductor is getting short circuit means what is the current? I is equal to simply voltage is divided by resistance by Ohm's law. Voltage is 100 volts is divided by 20 plus 30, which is equal to 2 amperes. So what is the inductor property? Inductor do not allow the sudden change in current. Earlier when the switch is at position 1, it is carrying 2 amperes. Even when the switch is moved to position 2 also, the same current will carry, that is 2 ampere and 2 ampere. At t is equal 0 and 0 plus also. Okay. At when the switch is moved to position 2, so this is a circuit diagram. For this, the inductor will carry the same current 2 ampere and 2 ampere. So this is out of that, like if you see in transient and in steady state, what is the inductor position? This if you understand, you can do the transients better. So in transient, inductor will act like a open circuit and capacitor will act like a short circuit. In steady state, inductor will become short circuit, capacitor will become open circuit. So the same initial condition I'll use for the third equation. What is the I of 0 or I of 0 plus? Any one condition I'll use. I of 0 plus is equal to, in this equation, I'll substitute t is equal to 0 plus. C into minus 150 into 0 plus. E power 0, right? E power 0 is equal to 1 into C. I of 0 plus means at 0 plus condition, I is equal to 2 amperes. 2. So, I'll substitute 2. C is equal to, that C is equal to, I'll substitute in the third equation, then we got the final solution as current is equal to, I is equal to 2 into e power minus 150 into t. So this is all about the problem.